Right now, as you sit watching this, you might feel perfectly still, but you are completely oblivious to the fact that you are falling. You, the Earth, and our Sun are tearing through the void. Every single star in the Milky Way galaxy is hurtling through space at a staggering 600 kilometers per second. That is well over 1.3 million miles per hour. We aren't drifting aimlessly on some random cosmic path. Along with hundreds of thousands of neighboring galaxies, we are caught in a massive gravitational undertow. Something out there is pulling us. The destination for this one-way trip is a localized gravitational anomaly. It is a mass so dense, it warps the very fabric of our local universe. Astrophysicists call it the Great Attractor. To exert a gravitational pull this immense, the Great Attractor has to contain a mass equivalent to tens of thousands of Milky Ways. So why haven't astronomers simply pointed our telescopes at it to snap a picture? Because it is hiding. By a stroke of sheer cosmic coincidence regarding our physical orientation in space, the Great Attractor sits perfectly behind an obstacle known as the Zone of Avoidance. When we try to look in the direction we are moving, our line of sight is completely blocked by the dense, dusty, star-choked plane of our own Milky Way galaxy. It is like trying to look out the window of a speeding car to see what you are crashing into, but the window is plastered with a thick layer of mud. The visible light from the anomaly simply cannot penetrate the dust and gas of our own galactic neighborhood. Because of this massive blind spot, the Great Attractor remained a terrifying, invisible ghost for decades. We knew we were rushing toward it, but we were entirely blind to what it actually was. This map shows the cosmic microwave background radiation, the oldest light in the universe. Scientists relied on this data to prove we were moving. In the 1970s, astronomers noticed an anomaly. One side of the sky looked slightly hotter, the opposite side slightly colder. This temperature split is a classic Doppler shift. Light waves compress and appear hotter or bluer in the direction of forward motion, while they stretch out behind. This Doppler shift isolated our local galaxy's movement from the background expansion of the surrounding universe. We are being hauled toward the constellation Centaurus by a specific local force. The temperature difference across the sky was the undeniable proof of the undertow. It forced astronomers to find a new way to pierce the cosmic mud on the windshield and map the void ahead. Determined to see through the Milky Way's dust, astronomers turned away from visible light. They began using massive telescopes calibrated for X-rays and radio waves, frequencies capable of punching right through our galactic wall. When the ghost finally took shape, they didn't find a single monolithic black hole. They found the Norma Cluster, a densely packed metropolitan hub of galaxies colliding, merging, and radiating colossal amounts of X-ray energy. But the Norma Cluster lacked the mass required to generate this much gravity. To account for the missing weight, astronomers mapped the velocities and directional flows of thousands of surrounding galaxies. Those movement lines revealed that the Milky Way and the Great Attractor are both part of a single sprawling superstructure. Astronomers named this massive cosmic watershed Laniakea, a Hawaiian word meaning immeasurable heaven. The Great Attractor is the gravitational focal point of this supercluster. It functions as the bottom of the Laniakea Valley, marking the point where all cosmic rivers flow. Our home, the Milky Way, sits perched on the quiet, distant outskirts of this supercluster. The Great Attractor is essentially downtown, and we are making a 1,000,000-mile-per-hour one-way commute toward the city center. Which raises a climactic question. What happens when hundreds of thousands of galaxies finally pile into the center of the Great Attractor? Will it trigger the most violent cosmic collision in the history of the universe? We will never find out. The Milky Way is never going to make it. Even though we are falling toward the center at a staggering speed, there is a force at work that is vastly more powerful than the collective gravity of 100,000 galaxies. Dark energy. While gravity tries to pull Laniakea together, dark energy is accelerating the expansion of the universe. It is physically stretching the fabric of space-time between the galaxies. It is like running on an accelerating treadmill. Eventually, the space between us and the attractor will stretch faster than we can fall, permanently breaking our gravitational bonds. In a grand cosmic irony, the Great Attractor is an illusion of permanence. We are falling into the dark, but before we ever reach the center, the universe will tear our supercluster apart. It will leave the Milky Way to drift entirely alone, safely out of reach of the ultimate cosmic crash.